right. Okay. If you saw the text beforehand, we had some slight technical difficulties. It feels it's a little tight. Let's zoom out a little bit. We had some slight technical difficulties with my capture card, just deciding it didn't want to exist in the land of living. Welcome, KI. Welcome, Essenen. Um, okay, so we'll see if this thing goes to plan, but this should be a good stream. We've got all sorts of good stuff. We're going to talk about all the features that made it into, or are making it into 3.5. Ryan, welcome. I feel like we need like an official Binja handshake or something. Like, how do we need like a Binja thing. Let's see. So we're going to show off all the features that are slated, and just as a refresher, as a reminder. Okay, this is good. Screen share is working. I have to go through Video Ninja because the capture card, as I said, decided to give up the ghost. I literally spent about 3 hours, 4 hours yesterday just tweaking the capture card to get it working right, and I changed some like graphic stuff. So this is 4K for me, for example, now, and then it's 1080 on the stream. But if I want to do it 4K, I thought, oh, this would be great. I can go to 4K. Anyway, long story short, the HD60 died. Username, welcome. Okay, yeah, the plan for releases go like this, basically. We have a feature stream. Ta-da! This is it. Also, my camera. Go this way. We have a feature stream, which we're doing now. Then we will go like another week or two after that, and then there's a feature freeze, then there's a bug fix freeze, and then the release. And so it's just our testing kind of release cycle where we get increasingly locked down in terms of what we can and can't push to dev, and then dev becomes stable. So the goal is that any major feature has to be done before the stream. So any big like headlining feature has to be done now because we want people to have enough time to check it out, to go on dev. Smaller features, little stuff can go in kind of later until the feature freeze, and then of course bug fixes in the existing features can go. So with all of that said, let's check out what we've got. So as a reminder, this is Coruscant. Oh, also this is 3.5. So if you may have noticed, I tweeted, let's see, or Tooted or Mastodon or whatever. We're not on Threads yet. Need to go do that as well. But what's my Twitter handle? I should remember this. So this is 3.5. You'll notice. Wait, why are these? Wait, you can pin multiple things? Wait, what? Oh, I didn't know that. How did that? Interesting. There's multiple stuff pinned? Or no, it's just, no, Twitter's just broken. Oh, okay. All right, never mind. This is just Twitter being broken. Surprise. That's weird. All right, well, if it ever works. No, I don't want to sign in. I just want to see. Oh, that's probably why it wasn't working. Why is it going back to 2022? It does like a random selection of maybe like the best tweets or something, like by stars. Interesting. So you can't, I guess you're supposed to log in for that. Okay, well, I guess I can't pull that up, but the bottom line is, let's go over to here, which I don't need to log in to visit. And we'll look the way that we've been doing our releases now, excuse me, the way that we've been doing our releases is we have our milestones, and the milestones are code names, and then we decide the exact version number. I know, Marsh, it's X. Somebody in the office corrected me the other day, and I was like, you can pry the Twitter name from my cold dead fingers. I'm resistant to change. Also, what's the verb? If it's X instead of Twitter, you don't tweet anymore. You X someone else? Like, how do you, like, what's the verb form of that? I don't know if I've seen any kind of consensus on that. So you can see we've got 80 closed issues. We've still got a fair amount open. Zeet. Ooh, is that right, Ninja? Is that actually it? And is it Zeet or Zeet? I shouldn't get sidetracked. But yeah. I mean the DMX I'm down for. Yeah, X Twitter. Nice, Josh. So Coruscant, we still got a couple issues to close. But a lot of these are actively in progress, um, and we'll see. Hopefully, we can get all those in to the final release. But Coruscant is going to be 3.5. We have been back and forth about 3.5 or 4.0. Or some of the major features we wanted in 4.0, we want more testing for it. We don't want to try to rush them out. So you Twix somebody, maybe you Kit Kat them, you Twix them, Twixt, betwixt. I don't like any of these. I'm like, tweeting works. I want to tweet. Even tooting just sounds awful. Like I'm gonna toot at you, Mastodon. Really? You thought that was? I mean, you got the T alliteration, but so this is our roadmap. You can see what's done here, but the whole point of this stream is to first I need to make sure I've got the latest update. I think there's actually a couple of updates have landed. Oh, and I got to pull up on another tab here. I've got some info that might be coming to me separately. Oh, this poor computer. Yeah, this computer is like in great pain having to both encode and stream as well as do this, so it might take a second. It's Sidekick and a bunch of other stuff. It's not just Sidekick, it's projects, it's type archives. We've got a whole new design for the start page in 4.0. We've got a bunch of UI refreshes coming, a new theme by default. 4.0 is gonna like have a bunch of stuff on it. So that said, y'all are not getting shortchanged with 3.5. 3.5 has lots of good stuff. So you can see it here. This is the list, and what I'm looking for over here is if Josh, who is apparently done enough with his work that he can be on the stream, but he had another feature he wanted me to demo. So we'll see if that hits a test branch, and I will update to his version of the test branch, right? So depending on how that goes. So audience participation moment. Gotta take your dog to church to get its haircut. I know, yeah, I know. It's a common problem. Except to leave the office, he has to walk by. So I can see him. I can see him leave. Except, that's not true. He can go out the other door. We have 2 doors now. I can't trap them. So what do y'all want to see first? I probably would do time travel debugging as the first demo, but which I don't remember if I've shown on stream before. I don't know. I don't think Shushung has come on. I don't think we've shown that. So that might be a first on stream. Oh, also, let me fix this. I just realized. We did a podcast recently. Oh, there we go. My audio probably got way better now. Sweet. Okay, excellent. People have not seen time travel debugging yet. So I just realized the camera's in the right spot. It's the monitor that's not centered. That's why I got to move over here because I got to keep the logo there. Awesome. I think we'll do TTD then. Hype. All right. Excellent. Alexander wants 2. Yeah. See. Okay. All right. So TTD it is. Although you'll notice, I am on Linux right now, and Linux doesn't currently have any TTD support. So if you're not familiar, TTD is time travel debugging. And there are a couple of different things that have implemented time travel debugging. Oh no, yeah, this VM probably got all swapped while I left it overnight, so we'll probably have to restart all this. And in fact, this is also running an old version anyways. Yeah, so my VM is really hurting doing Video Ninja. You know what? I wonder if I can control... Video Ninja might be trying to stream at 4K, which would be excessive. So let me see if I can tweak that. I don't know if there's a way for me to control it over here, so for now I might just have to suffer. Hey Valgrind, welcome. You'll hear me talk extra fast. All right, so yeah, let's nuke this. Like I said, this whole I can hear this laptop complaining so much, and it's like overheating. And I'm betting this whole VM is basically swapped out. So let's no, you don't need to report anything. It's fine. It's my fault. It's not Binja's fault. So we'll just relaunch it. So what we're gonna do is talk about the instructions first. So use the browser over here. I'm trying to minimize the number of browsers. So you may know the dev version of the docs are available offline. And so user manual debugger, and there's a TTD section here. There we go. So the dev docs, you can always get to online there. And there's a whole section on time travel debugging where it talks a little bit about it. But again, the concept is go back in time. There are different implementations of it. Most of them in the form of like RR and Panda and WinDBG has time travel debugging. They'll essentially record a trace, and then you can go backwards and forwards along that trace anywhere you want and see the full state of registers and memory. And so it's incredibly useful. There's even a few other forms of it. If you're familiar with Tetrain, they got bought out by somebody else. They're now, Revin is the product, eShard. So eShard is the new company. They have a cool tech that is a little bit more powerful in that I think theirs you can, no, actually, I don't think any of the, that's not true. There's one public system that can actually go back, modify the state, and then execute again, and it's Deja VM. So, which is not super well known, but Raytheon has a tool that can do that. So that one can actually do like whole system emulation and time travel debugging like for real, where you can actually go back in time, change state, and then like do something else. What are we looking at other than X? Oh no! Did the capture not? Hold on. I'm sorry. I was like doing a bunch of stuff, but you're right. The stream, did the stream hang? Video Ninja, what are you doing? Okay, hold on. Let me make some tweaks here. And thank you, Aaron, for mentioning that, because this is not actually capturing my screen anymore. So hold on. Disconnect. Yeah, if y'all ever see me like clicking around and acting like I'm talking about stuff, let me know. But I think I need to undo my whole thing I did yesterday to set the display resolution here, and we need to go back to 1080, and then I need to change the where was the scaling? Here it's settings. So I'm going to my screen setting. Yes, that's what I want. 1920 by 1080. And then my i3 settings. All right, so let's restart my VM over here. And while I'm doing that, let us also reconnect here. Screen share with room. Select screen to share. Share entire window. Oh no, not share window. That's maybe part of the problem. Maybe that's no. Select screen to share. Share screen. Share this screen. Okay. Screen's back. Good. Yeah, exactly, Valgrind. So time travel debugging can be super nice. And like I said, most of the implementations like you draw this kind of trace, then you can go back through it. Okay. Reboot. Let's reset that setting. Okay. And now let's hello Windows, yep. Okay, cool. All right. So I can switch back and forth. Actually, hold on. No, I want display settings. Was that what I did before? I did. Okay, scale 100%, 1080p. Beautiful. All right, well, so now I get gross 1080p aliasing on my side, but you know what? It works, and that's the most important thing. All right, so let me know if it looks like things lag again. And now I'll start over in terms of what we're pulling up. All right, so we're updating that one. Let's go back. Our VM is up. We've got there. we've got Binary Ninja Enterprise. We're gonna launch that. And then we're gonna launch a browser. Let's go look up the WinDBG TTD and also the dev docs time travel debugging beta. Okay, so WinDBG has their implementation of time travel debugging, and you can essentially record a trace, and then kind of like you can use this timelining and debug inside of WinDBG with time travel debugging. But you can also do it in Binja itself. Ledger font. Okay, yeah. Let me know which Ledger font in Binja here. Yeah, let me know. Yeah, actually the Binja default font. Let me just crank that up a little bit on both VMs. In fact, actually the font's about to get smaller too here, ironically, because there's a new change on dev for Windows fonts in particular. So as soon as I restart, it was going to shrink the font. But by changing that setting, it should be better. So let me know. Oh, also, watch this. Someone say something in chat. I've turned on ultra low latency mode on the stream. I really want to see how long the lag time is. So someone say something, and I'll tell you as soon as I see it in chat. There we go. Say something. Something. Okay. There we go. Several people. So I think that's pretty fast. Like I went from like normal latency to like the lowest fastest latency because I was realizing I was super lagged. I guess I could just like go on another computer like too, but it was a trick to make sure people are awake. 4 seconds, perfect. Okay. Oh, does it actually show you in the UI, or you mean just like based on my response time? That would be nice. All right. So let's open up this Crack Me, for example. Let's go check how's our font size now. Right click in stats. Very nice. All right, so we're gonna just go 13, size 13 font. Let me know if that's big enough or if I should go larger. I can also just listen very carefully, and I can hear Josh and Glenn in the other room. Okay, so what we could do is, so first you have to use WinDBG, right? So let's open WinDBG. Now there's a couple of steps that you have to do as well here too. So this again is the explanation on Microsoft's website about their implementation, how to do it, and then this is the guide on the using it with Binary Ninja's built-in debugger. So first step is you install WinDBG itself. Make sure you're on the latest dev, which we certainly were. And then this has a couple of extra steps that I didn't follow the directions. Shusheng was like, did you just do the directions when I had troubles with it? And I was like, oh, maybe I should have done that. So there is a signing issue with the way that WinDBG, WinBag, if you prefer, is installed by default. And so this Windows Apps folder is like protected. And so you can't actually get into that, which means you can't call into like APIs that WinBag exposes. And so the temporary workaround is essentially you just copy all those files into some other path, and then specify that path in the Binary Ninja settings. So that's one thing that I did beforehand. So I installed it. I copied the files over there. There is an issue here. You can see tracking, kind of doing that automatically for you, putting it in like a temp folder or something. WinDbag. Oh, that's not bad. I don't think I've ever heard that one before. WinDbag, because, well, it has other issues with it, but yeah, that's it depends on how happy you are with it, whether you call it WinDbag or WinDbug or WinBag. Yeah, that was kind of done. I did that one already, but now we're gonna do the rest here live, right? So we're gonna record a trace and we're gonna connect that trace to Binary Ninja. So back in our other VM, I'm like, where'd it go? Here it is. Back in our Windows VM, let us go to File, and you'll notice this one specifically says supports time travel debugging, and so does this. So we're going to do the advanced launch. We're going to run Crack Me. That doesn't matter, and we're going to enable time travel debugging. So it wants to know where we should put the recording, and you'll notice I did this a couple times yesterday. This is how I found my errors. And so you can see we have existing runs of it, but we're going to make a new one, so you'll see Crack Me 3 will appear. There's a .run file, an IDX, and an out file. I have no idea what the differences are, but let's see. Yes, I want to allow that. And so here's some crack me, and it's compare me to something. All right, so I'll give it some input. It says, no, you failed, and then that's it. I've generated my trace. So if I look back at that folder, I've already got crack me 3, all those files, and so that's all we need. We should be able to now close WinDBG, and from Binja, bring up the debugger for that same file, the crack me file, but we're going to configure the backend that we're using. So instead of using the native debugger, we're going to use the TTD beta. And that one, you don't point it at the executable, you point it at the trace that was generated. In other words, that .run file that we saw earlier. So let's pull up crack me 3 and make sure it's the run file. Okay, so let's double check that. Again, we go back to our Binja docs. I can see record a trace, we do all that, do whatever you want to do, read how you can interact with the debugger while it's going, and then open the file in Binja, change your settings, we've done this, and that's it. So, okay, let's give it a whirl. Let's accept that. Yes, that is what Shusheng did. I believe he used the TTD bindings that they expose. You can actually see this because our debugger backend is actually open source. And so if we I bet we can go in here and just look for TTD. There's the fix that he did. That's the docs. There we go. So here's the commit where he added, and you can see there's a debug eng adapter, debug eng TTD adapter. So let's go look at that. That is under core debug. Let's find TTD. Where does TTD go? Oh, adapters, right? Adapters, debug eng TTD. So we're implementing a binary ninja debug adapter, but we should see. Let's see where it actually uses the API. I haven't actually looked at the source code yet, so I'm actually curious too. Debug control. Where does debug control come from? That looks like, this looks like the WinDBG API. I assume debug client, open dump file. Set execution status. So where did we initialize? Oh, is that past 10? Oh, maybe it's not then, if that's the case. Let's see. Well, actually here, what was our include? Just the header. Yeah, I actually don't know. Debug adapter type. I don't actually know where it's using the, like where it's actually calling. Oh, it's sorry, it's the debug gen. There we go. Is this? No, that's actually the installer. Unless it calls it out of the parent, like it exposes a different one but uses the same APIs. I bet it does. Is it implemented on top of the other debug eng? Yeah, so the debug eng is the Windows debugging API, right? Let's see where it's actually calling it. But yeah, I assume it's in there. Yeah, exactly. So the GT commands, right, exactly. That's why you know it's the same thing. So you were commenting here, right? These commands, it's using the same syntax as WinDBG itself, which is debug eng is their engine that NTSD, WinDBG, all that uses. I don't even know if is NTSD even a thing anymore. It used to be. You can tell that I started my career too long ago. So in those commands, for example, well, let's go ahead. Let's actually run this, right? So right now we've just configured the debug adapter. So we've said use the TTD implementation of the debug adapter. Now let's actually run it. And of course, it's not really running it. We're loading this this trace file that we've already generated. You see we get a few extra bonus views down here. So we can see the modules, and we've got our debugger console here. And this is where, like, again, this is just like the WinDBG console. So I need the commands, even like the bang, whatever command. Actually, wait, the dot ones work? Do the exclamation mark ones work too? Yeah, they do. Right, so you have access to all of those normal stuff. Just like if you're using the LDB backend, you have the same thing. There's a console that you can interact with the debugger. You have the target console of the app you're interacting with, and some of these other kind of views here. So this is like we can do things like single step from here, which I honestly prefer. So there are buttons and hotkeys, and in fact, I think they default to the same as the Windows ones, like what is it? Single step is, yeah, this F7 is for single step into. One other thing I like to do when I'm debugging too is I like to look at both disassembly and high. Actually, I'm going to swap these two. I want to put high over here, and I want to have disassembly on the left. But I like seeing them both, and sometimes there's a time and a place where you want a single step in high level IO. But let's just like start single stepping, right? So you can do NI or N, N, SI. Now T, wow, I'm GDB. Sorry, obviously I was confusing my GDB with so T or S are step or step over, I think, right? Can I G question mark? Past count must be preceded. Okay. No, it's not S. It's T and I forget which one. Yeah, exactly. So you get sort of all the benefits of if you're familiar with the existing debugger, but you're getting all of the output of it and the UI for it inside of Binja itself. And you can implement support for other debuggers too. And having support for things like GDB protocol and GDB debugger means QEMU or other things you can just kind of wire up and get the same thing. But you can also, this is kind of a fun trick, you also have the Binja API. So this is actually really neat too. A lot of people don't know. P, thank you, Ninja, that's exactly it. Yeah. P, it's N and P. T and P, T and P. Yeah, so one is step, T I think is step into and P is step over maybe, which is the weirdest, like I feel like N and NI and like that's a little more intuitive, even though I used to spend a lot more time in WinBug. It's been a while. So anyway, enough of this boring stuff. Let's just like go, by the way. Let's just try this. So if I just G to, oops, and I do it in the console, or I can put the resume, play, whatever, F9 button over there. I can just like go and see what the debugger does. And it's just going to go all the way to the end, right? It went to the end because there was nothing, there was no other breakpoints and stuff. So let's just go negative, right? So that's like all the way back to the beginning. And so this is for PTEP. Nice. Yeah, exactly. Like what? I mean, I guess T and P are in the word step, and so it's like S was already taken. But like, I don't remember, what is S even taken for? Search? No, that's MS. MS is memory search, right? Or is it search? No, S is search. S is search already. But I feel like stepping is more fundamental than searching in the debugger. But I don't know. You could tell that WinDBG had lots of people work on it over the years and had their own hotkeys and things. Especially when you start getting into like the dot and the exclamation mark, and it's like stuff's all over the map. All right, but let's just start single stepping. So let's come in here. We're in this. So let's like GU to like go up out of that function, for example. Oh, I went too far. Right? If I single step, yeah, I'm stuck here. That's the end of the trace. Hold on. I'm in start. Let's step over. So I hit P, and now let's T to jump into this. All right, so now we've got something that looks like still regular init code. Again, we can kind of come down here. All right, so here's a function call. Maybe it's this one. Let's poke it here. Ah, there we go. I see a password there. Okay, so like I could, for example, Control-Shift-A, copy that address, and G space that address if I want, because I used to the command line, or, although I say that, but I haven't been remembering the keys very well. Or I could just set a breakpoint here, right? So if I can do it with F2 with the command palette. I don't remember what the hotkey is, so I just do it that way. And now I should get the same behavior. We go to the breakpoint. Cool. So we're gonna check for our password, and this is yeah, some wrapper for some console thing. So it doesn't look important, but it's okay. Never mind. That's a string, right? So it's a format string. So this is presumably just a printf, and there's probably an extra argument here that we don't know about because we don't know that this is basically a printf. ACRT IOB. Actually, I haven't looked into that before. So let's call this printf wrapper, and then let's give it char star fmt, right? And so we could then say, for example, override call type, which is nice. We can say generically, we can say it takes oh, wait a minute. Hold on, did I just change the name of it? Oh, I did, didn't I? I hit Y, I didn't, or I hit N. I didn't hit Y, so let's undo that. You notice that Binjo was happy to let me to do that, so I hit Y instead. There we go. Oops, just these parameters. And again, like I'm doing this on the database, in Binjo's view, but in the decompiler as well. I'm kind of mixing the decompiler with this, and sure enough, now we can see that unused parameter shows up there. And so I've got my format string, and I'm gonna print whatever goes into here, I guess. But this is oh, this isn't printf. That's that's like a scanf or something, right? Yeah, sorry. So that's not printf wrapper. Nobody called me out on that. Probably scanf there. So let's just double check. Let's tell this go to this address, and again, this time instead of setting the breakpoint, we're just going to do it here in the command line, so we can see we've jumped past it. Aha! Well, that's cool. We've already got this thing on the stack, and it's why is it? I don't know. I actually know why that annotation is going there. That's really interesting. But if I pull here, I should see it there, right? So that string got put into raw memory, right? And so I can annotate that, and we can see the results went into that destination. So now we're going to like presumably check, and actually, I'm a little surprised. That's probably actually still an argument, right? I would think that the scanf. Yeah, I feel like it really belongs as an argument here, but I don't know why I'm not seeing that. So this one claims it has no argument. And then here we can see. Okay, so there's some built-in mem copies. We see those rep move SDs get turned into mem copies. All right, so presumably somewhere in here, one of these functions, I'm gonna find my my string getting like checksummed or some other kind of like a little simple crack me. That's the same thing actually. Oh, hold on. Actually, you know what? I think. Okay, so here is interesting. We've got this check. The same function is being called a million times. And here's an example where I would like to split this up or see this maybe vertically. This is something we're working on or we're rather thinking about, like how do we improve, is that the way that like very long folded conditions are done. This could be a little prettier, but so presumably this is the win function, right? Oh, yeah, so there's something obfuscated happening here. Is it obfuscated or is it just a checksum calculation? Let's see. Yeah, right. So this is just a bunch of math. It's interesting. We're seeing it here. It's just yeah, I'm not sure about that. But all we're doing is calculating right, so we're writing into here. Oh, incorrect. They didn't want you to see, maybe. Did we? Yeah, do we not want to see that this is a pointer to a string? So it kind of just obfuscated to like Right. So this is okay. So this is saying incorrect. I guess it's setting the value that return. I think we're also losing some parameters through here. This feels like there's some optimization where the stack parameters are um, being missed, maybe, and that can happen on 32-bit x86 depending on like uh, you don't know necessarily know the arguments that are passed to every function. So you kind of have to the analysis kind of has to guess. Anyway, so I'm gonna call this one fail or incorrect, I guess, right? So if it's not equal, so in other words, we have to get those to be equal to 0. I'm not going to solve the full crack me. I should probably stop getting too excited in this. But the point of all of this was to say, oh, that's funny. Yeah, hint decompile this executable. Yes, yes, we should actually verify this. And then here's our check something, right? Checksum is some sort of verification thing that we're gonna do here. So let's go to here. So I hit Control-Shift-A to copy the address. And now I'm in this one. So now, like, we want to look at like the arguments. Interesting. So we've got which are these pointers? These aren't pointers. Interesting. What are those two? So we can just hover over them. We can see the memory of these registers, and then we can start if we wanted to start single stepping. I can also again use the UI here. Did I? Oh, I know what. I think if you have the high level IL selected, by the way, you notice how it jumped several times? It's because I had the high level IL selected. A surprise crack me distraction, or a surprise malware distraction, or a surprise Jordan's easily distracted distraction. Exactly. So like, let's just say I want to like just start single stepping through here, right? So I'm going to be doing my T's. And actually, you know what? I did. I wanted to go back to that address though, right? The problem is it was all the way back up there. So what if I instead T negative like 7? Oh, that's right. You only get one at a time, I think. Yeah. So I can T negative and hit enter a couple times. Let's jump all the way back up here. Oh, yeah, there we go. That was it. We went too far because we were single stepping in the high level file. And now, I know all that work just to demonstrate this this little feature that you can now go backwards in addition to forwards inside the thing. So anyway, I'm not going to actually calculate the checksum here and figure out what it's actually doing to succeed the crack me for now. But there we go. That's time travel debugging, and it's also nice because you can do your analysis on another machine that's not like if it's malware or something, right? You could pull that out. Oh, okay. Like a memory, yeah, memory access breakpoint. Yeah, that's a good question. Let's see. So let's find where we currently here. So that's a load from let's see here. What's the function to like calculate the pointer address? Well, actually, I can just look at it here. I know it's going to load from here, right? So, oh yeah, that's a great place to so let's break on access of that address. It's for 703B0. Thank you for the syntax, by the way. And do we want? Yeah, let's fine. We'll do that. I'm trying to remember. Break access, or do I have to give it the bracket? There's a way to get .hh. Oh no, .hh doesn't work. Oh, that's right, because that pops open the GUI, I think, in 32-bit. So just 32. Yeah, let's see. Unsupported data breakpoint size. Yeah, so let me actually bring up WinDBG and let me try this. Where's the console? Did they get rid of it? No, command. Command? Where's the, is it down here? Looks like a support chat button or something. That's not it. Do I have to actually be attached to something? I might have to be. Oh no. Oh, right, W4, it's bytes, not bits. I understand. All right, y'all still see my screen? Okay, good, I lost it, it flickered for a second. Okay, so BA W4 OX4703B0. Okay, and now let's go. Oh, we were at the end, oh no, but now let's go negative and see if we hit that breakpoint. Oh, interesting. Okay, we hit a breakpoint on inc edx. There's no way that is breaking on our... Wait, does it breakpoint if the pointer is used in the calculation? Because edx is equal to that pointer value. I didn't think it did that. Interesting. Does it really? I wonder if that's a feature of just the TTD. I don't think I've seen that. So let's go back negative again. Yeah, so let's do tneg1. No, I think we're hitting this loop. So this function is called in a loop. Yeah, and each time edx is the pointer to that memory location. So it's counting that as a use or as a memory access, even though it's just incrementing the register that contains the pointer. Huh. So if I tneg and now gneg, it's probably going to go back to the same thing because I think that function was called. Oh, there we go. Different one. I think I did this wrong. Hold on. It doesn't feel right. Where was our checksum? So here, wasn't too far from here. We should be able to. Oh, except that ironically, yeah, the memory's changed. That's kind of cool, right? So we can scroll around and look, but the memory's actually changed. So if we just go forward and here, and now we want to go, oh, interesting. Oh, that loop as a whole is modifying the memory. So the breakpoint is working because that is the value, right? And I wonder if I unsync this view and then make this the main. Let's try this. If I now step back negative, or rather go forward a couple times. Yeah, watch it. Watch it writing that. So the memory breakpoint is actually firing as it writes there. It's getting me the function for some reason instead of the instruction. Yeah, and the breakpoint only got the first 4 bytes because we set yeah, I mean, it definitely was that breakpoint because that was the pointer that I wanted to breakpoint. And every time it wrote those first 4 bytes, we got we were breakpointing on a write to that address. That's what we were doing. Yeah, so Aaron, I was setting, so BA is like break on access, and like you can set different, I forget the full syntax on it. You can say like reads or writes, and I think I just set I was setting a write breakpoint on that memory region, so I could actually see when it was being written by the scanf or whatever it was that was pulling the console data into that global data variable. And so what I'm doing is I'm like telling it to go, like continue execution again, and the breakpoint triggers again as it was writing the next byte. So like if I go G negative, G negative, G negative, you can see it's, and remember we set the breakpoint, we said 4 bytes. So here's a pointer like at this location, there's 4 bytes I want you to like tell me if it writes to. So any of those 4 bytes get written to, the breakpoint's firing, and then after that it just keeps going. So I think that's, so that's the, it works. You can go back and forth on the memory breakpoint too. Very cool. I still, I would like to fiddle with a little more to figure the rest out, but welcome, kilohertz, RQHZ. Kilohertz rolls off the tongue. I don't know if that's actually right or not, but Good to see you. Okay, so that was a long time on just the time travel debugger, but I mean, you could spend a whole stream, obviously, just playing around with this, doing some actual reverse engineering. But that's cool. Yeah, so the debugger is definitely coming along. I'm gonna kill this VM because this poor laptop is really struggling with the screen capture and with the stream, having to do the video ninja instead of hardware capture. So let's switch back over here for the remainder of our features, and we'll try to go fast. We'll see if we can keep the rest from being so slow. So there's our TTD on that little crack me. That's exciting. Dwarf import and export. All right, so that reminds me, do I have samples? Yes, I do. All right, so here's a little Hello World application. And then what I've got with it is I've got a binary, but then I've actually got a DWO file, a Dwarf debug file. Oh, sorry, I just missed a couple chat messages. So Aaron, when you say is there a way to change the calling convention, do you mean inside of Binary Ninja? Do you mean, yeah, in what context? But yes, in general, absolutely. Like, so if this file right here, for example, edit function properties, I can change the calling convention here. You can add new calling conventions too. You have to use the API for that, but you can add your own custom ones as well. But that's how Binja itself does that. Yeah, so the two files we've got here, we've got an actual executable, and then we've got this Dwarf file. So if I open the file, I should be able to do this new thing. Oh, that's right. We got to go to settings and search for Dwarf. And so you'll see one of these is off by default. I've turned it on here, but this import plugin is off by default just for more testing purposes. So that should be on by the stable. We're doing a bunch of testing internally to make sure it's good. But because I've got that on, actually, I should have... actually, in this case, right, in this case, that's an external debug info, right? So this is a new plugin that can both load Dwarf that was in that file or load it from an external file. So import debug info from external file. And this is the same API that you can use with things like PDBs, with anytime there's debugging information, you can do that. And it also will automatically, the debug info APIs will also automatically find they're the thing that triggers a PDB or any other like external debug info. So hence the name. So if we give it this, and now we tell it point at the DWO, we can see there are 317 functions from debug info, right? So we've added, oh, we didn't apply them though. Oh no. Oh, Kyle, this was your demo files I used. I'm not sure if, let me try something else real quick. Make sure this is not how I'm using it with Enterprise. So if I open the file and I go to samples, let's open it here. It shouldn't make a difference. This is why we test and why we have a whole month. No, okay, it's still not applying it. So I'm not sure why it's not actually applying the extra debug information it has, but it should still be pulling in the types. So now we can come and we can see, yeah, there's 107 types. If I go to this, there's still 107 types. What happened? I thought this pulled extra type information. Well, that makes me sad. So I didn't test this demo, but I should have. I did do a different one I can show you as well, because there's a couple other use cases for this. Something else we can do is we can take a binary that we've annotated and we've made changes on, and we can export all the changes we've made, right? So actually, we can use the same file for that matter. So let's go find a function that we. Actually, that's not a good example. Let's go find a different file. Oh yeah, this was the other thing that I did, which is a little bit spicy, is that I opened up a DLL that I know has a PDB, and then I can take all the PD information that's applied on top of it and then export that as an extra debug file. So maybe you have something that can read Dwarf but not PDB, and you can sort of use this to port all the debug information. But even above that, you can you can add additional. And by the way, notice this one's fast call. The other way you can change file calling convention is with this syntax, this under whatever the calling convention is. So like if I wanted to call this instead, hi.
Screen capture is real blocky.
Screen capture is real blocky. Oh no. Oh. If I wait, does it get better? It's like because this machine's overheating, I think. This poor laptop can't handle. I suspect. Let me see. Is there anything else I can nuke or kill here? Like,
it's really chugging a lot.
oh, my poor. Hold on, let me make sure. Did this actually get shut down? This one got shut down. I only have the one VM too. Yeah, I can just see it even like here. Ugh, oh no. All right, hold on. Oh, that does look gross. Hold on, let me make this full screen. I can at least see it more easily. If I wait, it gets worse. All right, I can at least. Oh, that's awful. Okay, hold on. I don't want an audio source detected.
We have another capture card.
No, we don't have another capture card. Not that we'll do pass through. That's the problem. Is that what? Hold on. All right, I do have one other option. I can try something. Let's try one thing real quick and see if we can modify how this is working. So if I output my I can do this. I got an idea. Give me a couple minutes. I apologize, chat. I think I have a plan. Let's see if this works. I can duplicate my output to two different displays. One that goes to the monitor, one that goes to the other capture card.
Oh yeah.
And then bye face cam. No face cam. And then I have to change my display mirroring settings here. Y'all can still hear me, right? Surely the green lines are a good sign that things are working, right? Okay, so hold on. Let's. Oh, this poor laptop. It is like unresponsive. Yeah, no wonder the encoding wasn't working because like the laptop is just hating life.
Not happy.
Which is weird because the same laptop I've used Video Ninja on this machine before on the stream. And that was back when the laptop wasn't as, like, I nuked it off and it's like a fresh install, basically.
Oh, looks like it's just a laptop. Is it still chugging?
Yeah, I want to see if, in fact, it's literally, oh no, its power's on hold. Okay, let's go check what CPU usage. Let's see here. Apologies. Hopefully we can get this. Is it disk?
Are you doing a backup?
Yeah, did Time Machine kick off? I don't think a Time Machine should be off. That's a good point. I mean, it's not. Chrome has. Oh, hold on. What is Chrome doing? Why is Chrome even running on this box? That could have been old, but hold on. Let's see. Did that make things better? Oh, hold on. Okay, okay, that's better. Now, next thing's next. Hold on. Let's go back here. You all still hear me? You still hear me? You can't see me. Let's try webcam. Okay, all right, we're getting closer. We're getting closer. So next step is I have to go to my displays and I arrange, and there's a trick where you can, if you hold Option on a Mac and drag one display on top of the other one, you can choose to just mirror two of your three output displays.
Oh.
So I still have my laptop screen, and then I have my mirrored one. So I have a monitor. Hey, winning. Okay, okay. Hello, Jessica. Yes. Yeah, exactly, right? Like any surprise that Chrome would be just destroy my CPU. Okay, so we've lost Facecam. I mean, I could put back.
There's the small one.
There is actually this webcam. Let me go back to desktop and make this. Fit to screen. We can add video capture device, other cam, and do that from the Logitech. Okay, so we've got this camera now. It's not the best cam, but it's a cam. All right. How about now? And let me move the camera over. Okay. So now we can see, now my poor laptop is not trying to stream and output and everything. All right, good. No, thank you for mentioning it, everybody. Sorry for the trouble. Okay. Cool. This is what I'm dreading next week at Hackasat and Live CTF, that we'll run into stuff like this, but that's why we have backups. All right. So where was I going? I was mentioning that the other way to change these, the other way to change these calling conventions, like instead of fast call, if I want to change it to this call, you can actually hit Y and just change under this call. So you can do that as well too. To change the calling convention. So just another little side thing. All right, but yeah, the Dwarf stuff, basically import export on Dwarf. Obviously, it still has a couple little bugs. Like I'm still trying to figure out why it said it wasn't loading the symbols here, which makes me sad. But we'll figure that out. Yeah, this one did not apply them for lack of provided platform or address. That's a bug there. So, all right, next one up. Let's get back. We actually have a lot of stuff. Oh, and I want to see. I'm gonna pull up. Hopefully my laptop is not melting anymore, and I can bring up. I'll bring up the chat over here, and then I can see if Josh tells me if there's any test builds coming. So he's got one running. All right, so let's go back to our list. So we've got Dwarf, lots more to go. Heuristic pointer analysis. This is a good one. So this is something that we could even be a little bit more aggressive on. But what you'll notice is
It's already finished.
the test build.
Yeah, it's
Yeah.
5111.
Oh, did you already tell me in the
Yeah, very fully.
in the chat? Hold on, I gotta. That's what I'm saying. I didn't have the chat up here. So, all right. Oh look, I got a message in the chat. Oh, there's a new test build, and no one knows this is coming. I think unless y'all have been reading the test branch names. So this binary, and for comparison, here I want to bring up. We're going to run binary 3.4. So this is the last stable build, right? So we want to look at the difference between the stable and the current one. And I think this is, yeah, it should be the last one we've opened. So you'll notice if you run a non-enterprise build, you don't see the names of projects, but you still have the full same file. They still show up in the recent list. So I can use that. I could have also popped open an older enterprise stable. I just didn't happen to have one handy. So this is just to show the sort of like before and after. Right. So it's a piece of malware. I'm not, when you wait, is that the right one? Hold on. It doesn't, is that the right? Oh no, it is. There's the name 34. Okay, yeah, 34E. So it's the right one. But the other thing I did was I used the chat function on Enterprise, which is kind of a nifty feature. So I can put little bookmarks to myself for things I wanted to look at. So here's an offset, for example, where we can just see there's a couple of constant values, and then there's these function pointers. Like, not a big deal, just some function pointers. But if instead I go back to the stable build, so again, this is on stable, I do not get that, right? Not, in fact, you notice you don't even get cross references to these right here. And then these, you've got just addresses and things are integers, right? So I can hit like O to turn these into like function pointers. Is the other right? Yeah, or I could actually change them into like void stars. That's the other way to do this, right? If I want to make them, I don't remember if there's a hotkey to do that. But you don't have to. Over on, you notice in the latest Binja, it's just done for you. So it automatically recognizes those. However, it's not perfect. There's definitely, it could be more aggressive. But in the interest of making sure we didn't have any false positives, it's kind of a cautious improvement. So you'll still see things that were, in fact, this is a good example. Here is a string, right? That could have been turned into, actually, it's not so much a pointer. There's a separate one that does the string references as well too. But yeah, so there may still be things that could get improved on, but you'll notice that's more more accurate, and you'll see there's cross references to those. Let's see, to these functions here, right? You can see where they're actually getting used. So those pointers, it's doing a deref through the global pointer, right? It's pulling out the actual address through that. So those get turned into pointers now. So that's nice. The next one, I'm going to jump down actually to variable name propagation because it's the same test file that I'm using it for. So it's convenient while I'm here, and we'll talk about the rest separately. The variable name propagation, and so there's two things that it does. One, things like for loops. So for example, wait, is this the right? There we go. I don't see BA. I don't see it going to the right address. It's maybe one of those ones that shows up multiple times. So I'm just going to search for, in high level IL, if I do a search for 4, and we look in high level IL and we do a find all, you'll notice we get a bunch of search results, and we can see for loop counters have names like I and J. And again, they're nested, right? So for example, this one is nested inside of this one. So you've got an I, you go to J. So it just makes things a little bit reader. It's just kind of a nice touch that those get renamed. The other thing that happened here is the renaming of variables, right? So this is something that makes, it's a really sort of cheap and easy kind of win because, you know, when you've got the return type that you know, or the return of a function like a Windows API, all the Windows APIs, if you know something is get module handle W, for example, well, you know you get back an H module. So just set the name on the return value. So that's super nice that you get all that. So anybody who does a lot of Windows API stuff should notice things just get slightly easier to read. Here's another one, DW error code right there, right? So the variable name as you look through that usage in the function is not like var under whatever or data under whatever it actually gets stored into, but it has a more useful name. So we get better default kind of naming. Definitely have some more plans to improve that. I think there's more we can do, but it's a good first start. Like I said, the loop counters and the variable naming really helps out a lot. So those kind of go together with the next one. So this one I have talked about on stream before, and this is one of our test cases that we've used internally. But division and modulo get implemented by compilers in all sorts of weird ways. And so in fact, you'll see there is a massive set of every combination of size of variable and compiler and architecture, you know, all that can impact how the compiler does these optimizations. Oh, thank you, Glenn. Good point. I got that wrong. You're right. Yeah, sorry. I said it was called H module because of the return. It's not. It's called H module because get proc address, the first parameter of get proc address, is an H module. Yeah, other way around. Right. So it got the return value here. It was able to, it got it back here actually through here. You know, the other one would be if there was a variable here instead of a string name, this name here would be given to the variable. So it's actually the other way around, right? Get proc adder is the one that did that. And let's see, error code likewise is set last error, right? So it's actually set last error that has the variable name error code that gets associated with it, not get last error. Yep, thank you. For multiple things, I think it's supposed to split it. Don't quote me on that, Ninja. But I mean, there is, so you already have the ability to split it. So I could, for example, yeah, it's telling me you shouldn't do that, and it's right. I probably shouldn't. But if I do that, yeah, I'm not positive on that, but I think it will split, or it can. But I don't know. I would need to play with that a little bit more. That's a good question. Yep. There's probably some other ones. Like I said, you could literally just scroll around a Windows binary, and you can see, obviously. Oh, here's one actually. No, let's get proc adders. That's the major module. It's the same. Yeah, no, that one's the same one. It doesn't get reused. Yeah. So yeah, it definitely can help make things a little bit cleaner there, having better names to start with. Back to, oops, wrong file. I'm gonna close that old version before I forget. Yeah, but obviously those variable names wouldn't have been like this on the stable version. Cool. So for loops returned. Not return variables. That's, again, that is incorrect. It's actually parameter names. Right? Yes, it showed up as a return value because it came from somewhere else. All right, so back to mod div. Yeah, I've covered this kind of on stream, but if we actually look at the low level file, you'll see it's only doing shifts and multiplies. But what we want to show is division and modulo, arithmetic operations. And so you'll see, you know, we've got a bunch of these that are all improved. This is fairly exhaustive testing because different sizes, different operations, and different architectures, again, will all actually impact this. And so it's a really hard problem, and we absolutely do not get them all. There are definitely situations where we will still incorrectly guess, depending on, again, the version of the compiler, the optimization level, the architecture, width of the with the parameter, with the variable, all can result in different optimizations. So this is difficult to do, and I've looked at both IDA and Ghidra as well. Same thing. In fact, it's weird. I've seen samples where you have like 20 of these operations of different sizes, and then like they'll all get a different disjoint set of them. Like nobody gets them all, and the ones that, like, it's not like one's a superset of the other. They're just like different. So I think it's just different methods and different heuristics for recovering them. Different types of analyses. So it's kind of a hard problem. You can, there's even a plugin actually in, what's it called? Division and modulo deoptimizer that actually uses Z3 to recover that for you. And so it tries to use that, but that can be really slow to do at scale. In fact, I noticed when doing some testing that IDA is usually faster than Binja on a lot of samples on Dogbolt for a couple reasons. But one of them there's a load delay where we do some type library parsing that we do each time. That's a little inefficient. But when you open up one of these kind of binaries, even with not nearly as many as this, even like a small number, IDA is significantly slower. So I think whatever implementation it's doing for recovering these is actually fairly compute heavy. Just looking at kind of how they perform, it can, you know, a function, a binary with maybe only 100 functions could take as long as 15 seconds to analyze, when normally it's just a second or two to fully decompile the whole thing with these kind of things. So anyway, that's kind of a fun problem. And way more readable. Again, if we were to look at you know, stable, you would basically get what you get medium level IL, right? You would get these kind of operations. You would see the shifts and the multiplies. Yeah, exactly, Charles. You by hand, you have to try to like go put it into like search for some constant or guess or figure it out, like to try to figure out what it's supposed to be. Like, oh, okay, you've multiplied and shift and like some you can search for the magic constant. Sometimes that comes up, but just letting it give you the answer is so much nicer. And there is like certain patterns that usually get followed, but like I said, not all of them. And it's still not fully solved, but no other tool does. We are significantly better than we used to be, which is great. So. All right, last one is UEFI platform. So this was a kind of a surprise one Rusty snuck in a little while ago, which is the out-of-the-box support for EFI files. You notice that we have things like an EFI handle type. So there's a bunch of default types now built into Binary Ninja for just some of the base EFI specification. And so you can see there's like 1,000 types included if you open up any file that it gets detected as an EFI image. And the other thing you can do is there's a plugin that goes along with it called the EFI resolver. And so if I actually reopen, let's close these down. I think I can just reopen. I don't think I have to restart Binja for that particular plugin. Let's see. There's a resolve EFI protocols. And boom, you'll notice I just got a bunch more type information, right? So it actually will find, there's like a listing of like GUIDs and services. And then using those, it applies this type information. So you get, this is very similar to like EFI Explorer, if you're familiar with that, if you've done any kind of EFI reverse engineering. There was a previous plugin already called BN UEFI Helper, which has a number of other GUIDs as well, like a list of GUIDs and tables and type information, because it really can improve analysis. But yeah, there's an official plugin called EFI Resolver, which again looks much prettier. You can see it really has a lot of useful information. You get structures, which always is going to make your decompilation look good. So that's a huge boost to if you're doing any kind of EFI work. So yeah, that is 3.5. Oh, one more thing. Can I do it? Can I do the Steve Jobs thing? One more thing. All right, let's do this. I should have actually updated this earlier while I was. So here's I'm gonna launch Binary Ninja test, and we're gonna go to a specific version. So let's turn that off. Do not auto update. Do not auto update. There's that annoying race condition that it's like just annoying enough that nobody's fixed yet. So internal test builds, and yep, 5.1.1.1.1.1.1, all the ones. All right, so we're gonna update to that. In the meantime, anyone have any questions? And is anyone going to Hacker Summer Camp next week? I will not be at Black Hat, the conference, but I will be in Vegas all week preparing for live CTF and Hackaset, as I mentioned earlier. So if anyone's around and wants to come and say hi, you should say hi. You should let me know. I will try to have some Binja stickers on me. In fact, that's one of my to-dos, is to pack everything up tonight and tomorrow. All right, so this is the surprise feature that wasn't on that list that Josh just implemented today. He had a test branch that he cleaned up and polished off. Let's open, do I have that crack me? Let's open that crack me. Where did that one go? Actually, it's in samples, I think. Let's see. Oh, no, it's not. Yeah, we'll save it there, though. So let's download original file. Let's put it in samples. And let's open crackme.exe. So the thing that just got added is, it is Ninja. Did you read the test branch name? They are Charles. In fact, they are like one DEF CON CTF is on the way that the layout map is. You'll be, if you're walking in the hallway, if you were there last year, it'll be like the first door to the contest area is where the DEF CON CTF is, and then all the way at the last door at the very end of the kind of along the same side but on the opposite end, where if you're in the DEF CON CTF area, straight all the way across is where Hackaset's at. So I'll have a lot of running back and forth. You saw it at GitHub. Very nice. I love it. People are watching that one. Yep. So you can't do it on parameters yet, but you can do user-informed data flow. So, okay, if you're not familiar with what user-informed data flow is, it is an ability that a lot of people don't know about because before this version, you had to switch to medium level IL. You had to only medium level IL, you would say, set user variable value, right? So I can set user variable value and I can do things like make it a constant value. Actually, if you watched the stream a couple weeks ago, I used this to great effect. We were able to kind of fix the Binary Ninja had a bug that we could kind of hack around. And so it wasn't properly calculating some multiplication through an instruction, but we could just take the two arguments and then multiply them ourselves, use this API, and we could set it. But we had to do that API, we had to do that change only on the medium level IL variable because that used to be the only place you could do it. But I hear told now you can do that at high level IL, which is kind of a small thing, it seems like, but this is much nicer for not having to switch back and forth. It makes it discoverable. We hope that more people will find it because not a lot of people kind of know about it. I assume the stream is more aware of it if you all saw me use it before. But yeah, so we can now set user variable value. We can set, so like for example, that's not a good, if there's like a function you want to like hard code the return value of, get current thread ID. If for whatever reason I wanted to say, actually set this always as a constant value of 1, right? The decompilation will now get updated. And you'll see that like it's going to change all the rest of the analysis, assuming that's that particular value. And then used to, right, that's the other one. It used to be you could only do it, even at medium level IL, thank you. Even at medium level IL, you could only do it when it was first initialized. Whereas here you could be like, well, maybe I don't want it here or here. Actually, let's find a variable that gets used multiple places. Here's a good one. So variable 8 is first initialized to EAX, and then this thing goes on it, and then this thing goes onto it. Like, oh, that's funny. I didn't realize get entropy actually just literally XORs the thread and the stuff. Let's hard code this instance of it, right? So let's change set, wait, what? Split variable, no, where'd it go? Set user variable value. Oh, is that a global? Is that why? No. Oh no, Josh, I can't do it there. What am I missing? Yes, Charles. There's no, okay, exactly. So there's no like automated way of doing it right now. But that's one of the things that we've thought about using the API for is you could actually, it doesn't have a definition site in the function. Oh, because it's a parameter? All right. Well, that's not a good example. So it does have to be defined in the function, I guess. It just doesn't have to be. You can change it. How about this one? Does this have a definition site in the function? Yes, it does. So like we could, for example, just here change that value, right? Now we want to set the value to either be 3, 2, or 1, right, or whatever, and it would calculate at this point. In fact, at this point, it would probably like return false, for example, because it knows at that memory location. Well, actually, it depends on what the memory is. I don't know. But yeah, we could change the decompilation analysis. And you could, Charles, exactly. Right, it's a stack variable. That's all. That makes sense. Yeah. Okay, well, good. See, this is why we test things. So we find out the little stuff we can do. So maybe by... it's still before feature freeze. So yeah, Charles, you could exactly tie up like the user-informed data flow. There are other ways you can do it. Workflows allow you to do a lot of powerful stuff too, but user-informed data flow is much simpler. It's really cool just to be able to say at different points like this value equals this. There are some things about being able to like undo it and remove it. I know there's some open bugs around it. It could be a little bit more fully fleshed out, but it's already super useful. Again, if you saw the stream from a few weeks ago, you could just like annotate some data and it cleaned up the decompilation a ton. So it's really, really nice to be able to do that. Like I could, for example, just set EAX equals this constant value. And now the decompilation will show me as if that value were always set. So yeah, you could wire that up into your debugger and you could be like, copy the value and paste it in here and let show me what the decompilation would look like, statically going forward based on those values that you have. So that is 3.5. That is Coruscant. I wish I had the tweet though. Hold on, we'll pull it up over. Am I logged in here? No, it's not working here either. Because I wish I could show you the pretty image, but we got a cute little picture of the team in a totally not legally identifiable as the Millennium Falcon photo. If there's any coincidences, are purely the result of common tropes in things people wear in spaceships, in science fiction things. So anyway, it's fun. It's got a little bit of team. So go check out the Twitter if you haven't already. But yeah, that's it for the stream this week. 3.5 is coming. There may be a few other there's a lot of other features as well that are coming into it. We'll put more info in the blog post. You'll be able to see that when it comes out in about a month, after we do additional testing and throw stuff in there. So good to see everybody. Let me know if, like I said, let me know if you're gonna be at DEF CON. I'll bring you some extra stickers or something. And I'm gonna go pack and start getting ready. Somebody still in the chat? Y'all still there? Let me know if Facecam. Oh yeah, Facecam doesn't go to me at all because it's not actually Facecam. Awesome. Yeah, come on by. Sounds great. All right, take care, everybody.